Hello everyone, video 3 of module 3. In this video we discuss about how to model piles as boundary conditions. Before going through modeling pile, one thing I need to share with you about assign shell spring is if I come to area spring, you can see apart from this local location that bottom or top, we have another option by a user specified direction vector. It could be area local axis or global axis. So that would be local axis would be almost you can define, for example, axis local 1 or 3 or 2, or if you go for global axis you have x and y and z component, and that would be always in positive direction. So this is the one I would like to share with you before starting modeling piles. So to model piles, I actually define a section for pile. I can show you here in define section. So I have a 600 diameter pile, 40 MPa with this reinforcement arrangement. So I put the set modifier 1. The reason is pile is confined, and you really need to see how much moment you have in pile. Generally the top part of the pile you have a little bit moment, but not for the rest of the pile. So pile is purely under compression. If the pile is under tension and moment, then you need to play with the stiffness. If it's a considerable moment and compression, the modification factor for moment can be 0.7. If it's significantly under tension and moment, then you can even go for 0.35, like what we do for beam and slab. So you need to decide which modifier factor is correct for you. So currently it's 1. Now what we need to do, we don't need any support because pile is able to take all lateral and vertical loads. So I'm coming here, selecting all elements and apply no support. Also we need to do for lift pit foundation. So I'm coming here and doing the same. Now we need to model the part. How we can do that? There are few ways to do this. I'm thinking of first of all creating some other grids to give us chance to draw pile element below basement level. So currently we have minus 4.2, which is at the lift pit level, and then I want to introduce another grid line for different layers of the soil. So I add 2 more Z level. So one is minus 7, which is the area and the layer that we change from a stiff sand to sandstone, and the other one I can put it minus say 10. So here I can put these layers here, for example stiff sand, and the other one sandstone. Okay, and I press OK here. So I have 2 more layers. So if I come here and put deform shape Z minus 4.2, the next one is minus 10 and minus 7. So these 2 are here. I can activate the grid line. Now we need to see what's the easiest way to model pile. So for columns, I'm thinking of just have 1 pile underneath each column. So when we have just 1 pile underneath each column, literally the load will be directly transferred to the pile. So you don't need any big pile cap to transfer load. Sometimes you have, for example, 1 column, but you have 2 piles for 1 column. Then in that case, you need to have a considerable size of pile cap and also the thickness. So what I'm doing here, just to give you both examples, I'm thinking of just putting 1 column on 2 piles and the other columns on one pile. I'm not doing this for all piles, it's just a matter of replication, so there's no point to do this. So what I will do, I will remove all similar piles just to save the time, and just draw one of them for you. So I think these to be just these two to be remained. So I assume, okay, this one is for example, lighter column, so I will make it smaller. This one is heavier column, so I want to have two piles. So what's the minimum distance between piles? Generally, this is 3 times of the diameter. So in this case, because we have 600 pile, we need to come with, say, 1.8 minimum. So currently these 2 points are 2 meters far from each other, which is good. So what I will do, I will simply copy this. So this is 1 meter. So if I press Ctrl R or use replicate and put here -1 and number 1, I don't want to delete it, so I apply, and again coming here, select these two and put 1 and I apply. If it's long, simply I can move these nodes by pressing Ctrl M or using move command and come here and change it. For example, I want to have just 600 millimeter from the center, so I've changed it here to 0.4, apply, so it could be smaller, and this -0.4 and apply. So this is for 2 piles for one column. The other pile for this column, I want to make the pile cap smaller because I have just one pile below. So say 600 pile, half of a diameter each side. We have more for size of pile cap, so 300 each side is 1.2 in total. So this is 2 meters, so to 1.2 is 800 millimeters, so that would be again 400 millimeter move. So if I come here and press Ctrl M, I can use the same here, -0.4 here, 0.4 here, 0.4, and this one also -0.4. So this is a small pile cap I have. What will be defined the thickness of the pile cap, because there is no bending or shear here. It's just a matter of having enough depth to meet the requirement of the development lengths of the bars. Under tension or compression, depends on the type of load. If the column is fully under compression, you just need to maintain the development lengths of the bar under compression. If it's under significant bending moment, you need to have enough depth to have the actually embedment depth for bar under compression, full tensile capacity. So I leave these two right now, and I'm coming to this, and I think this is 1.8. So again, we can make them smaller or not. You guys can do this edit based on the size. So I show you how to resize the actually the pile cap. So we can do the same procedure here. Just select these points and move them in. So I leave it by now just to save the time, and I just apply the piles here, put 2 piles here, and then for the lift, what we want to do, generally piles should be underneath the lift wall. So that means we need to enlarge the pile cap here. Here, if we have 600 pile, we need to have 300 millimeter extra extension. So I need to come to let's use whatever we have currently here. Just so I'm choosing those joints and applying -0.3, and do the same for the other side. So it's 0.3, this one 0.3, this one 0, and this one minus 0.3. Okay, now I want to draw the pile. The easiest, I can go to the elevation and draw them one by one, but it's hard to find this joint. The easiest way is using extrude command. So if I choose all those piles, all those actually points, and I want to put my piles right at the corner of the lift pit wall, so I can choose this command, extrude line point to frame. The section I want to choose is pile 600, and what is DZ? So I would put this one 0. So DZ for lift pit, because lift pit is already at minus 4.2, to reach to minus 7 and then going to minus 10. So I can draw it at the same time, and then I can cut it to the grid line. So minus 4.2 to minus 10 is minus 5.8. So I put Z minus 5.8, and number is 1, and I press OK. So you cannot see it here, but if I go to the elevation here, you can see the piles are here. And if I want to subdivide them, I will show you. Simply you need to subdivide it with the grid line, and you have different actual lengths if you want to introduce different linear springs. So I'll show you quickly here, and I do it for the rest of piles. So if I come here and I select the other pair of piles this way, I can come to divide, and I can intersect it with current coordinate system. So which Z is here is Z is minus 7. So I put here Z minus 7 and apply, and you can see these piles are divided here. So we can do the same for other piles that we will do very shortly. So I will move back here. I'll select this one. So one pile here. So all piles are the same size, so I can select all of them at the same time. So I'm selecting those, and I'm selecting this element here. I leave the retaining wall by now. I need to explain you there is a minor actually edit here. So I'll select all of them, and I'm coming to extrude and extrude point to frame cable. So it gives you the same option. So coming here, you can choose your pile, and this time is from minus 3 to minus 10, so that is minus 7. So I draw this. Now I need to draw a pile for these elements. So I cannot put the pile here because I don't want, for example, go out of this area. So what I need to do, I need to put the pile at the middle of this area. So this is 1.2. I want to come to the center of this area. What I need to do, I need to draw a special joint which is 0.3 inside, and then I draw a line here and have this line for my to locating my piles. So I can come here and draw a specific joint, and that draw a specific joint would be minus 0.3, and I'll draw it here. So I have this one here. Now this is the center of all those foundations. So if I choose this one and choose this one, and then come to this and select this cookie cut at the edge, or I can come here and based on the point area on edge. So that give me the same option, doesn't matter. So you can choose this one, and then you can apply, and you can see these two are developed like this. And you can continue for the rest of the pile caps. So you're doing this. I'm just doing this one for one side of the wall just to save the time. So the other things we can do, just make it quicker. You guys just need to be a little bit creative in terms of using commands. So I can come here and I can select all these joints at the same time, and then I can actually even I can replicate it. So I can select them and then I can come and replicate and mention dy is minus 0.3 and I apply. You can see all of them are here. So now you can easily come closer and then you can select all shells at the same time. And select all those joints. And then you can apply this command. So all of them are subdivided now. Now what you want to do, you for example want to put pile at the middle of each of those, or you want to exactly follow the joint that you have column and you want to put the actually pile closer to this. If you want to do this, simply you just need to divide this by actually intersecting with the grid line. So that gives you exactly the point that you want to run the actually have the piles. So let's do this. So I'll select all those elements that they are not aligned. So this is fine. This is fine. This we need that I put already. And you can choose the other side as well, but one side is okay. I'll tell you what needs to be done later. Yes, so all of them are selected. Now I'm coming here and using intersections with visible a straight grid line, this option, and I apply, and you see now I have exactly joints aligned with these grid lines which are addressing the columns. So I will do the same. So I'm coming here, I'm selecting these joints. As I said, I'm just doing for one side of the wall. So this one and this one. And then I'm using the same command for extrude. So that would be 600 pi, and that would be -7 again. And I press OK.